All right, welcome to the part 4 of the June 2015 Common Core Geometry Regents. We're going to be doing the two 6-point problems, so let's get it going. In the water tower in the picture below is modeled by the two-dimensional figure below it. All right, the water tower is composed of a hemisphere, a cylinder, and a cone. Let C be the center of the hemisphere and D be the center of the base of the cone. So what we have here is the cross section of our water tower. Remember, a cross section is just if we cut this water tower in half, this is what our water tower would look like. So this gives us all our dimensions. So over here we have our hemisphere, which is half a sphere. We have our cylinder right here. And we have over here our cone. Now let's write down the three formulas we're going to need to solve this, okay? For a cone, they give you all these formulas. To find the volume, you all have to do is 1/3 pi r squared times height. For the cylinder, the volume is going to be pi r squared times height, and the hemisphere is going to be 4/3 pi r to the third, and we're going to divide that by 2 because it's a hemisphere. So these are the three formulas we need. For our first part of this, if we're going to find the whole volume, is we're going to need the radius of the hemisphere, and that's pretty straightforward. It gives us 8.5. For the cylinder, we're going to need the radius of the base and the height. Well, we have our height, that's 25, and the radius is also going to be 8.5. The reason it's 8.5 is because, remember, this right here is a radius of the hemisphere, and all the radiuses are going to be the same. So CB is the same as CA, which is the same as CK. So we have that radius. And then we have our cone. And this is where it gets a little bit complicated. We have the radius because if 8.5 is CB, then we know FD is also 8.5. That doesn't change. But we don't have the height. That is an unknown, and we need that to get the volume of our cone. So this right now is X. So what I'm going to say is this. To find out the height, we're going to have to use a little bit of trigonometry. And what you see here is that we have a right triangle, we have an angle, an unknown side, and a side. So we're going to solve this. So let's take this all to the next page, and we're going to find out the total volume of this water tower. All right? So from the previous page, what we have is a triangle. Let's actually draw this a little bit more accurately. Looks like this for our cone. The bottom was 8.5. This angle is 47 degrees, and we need to find the height. What we're going to do is just label our sides. X is our opposite. We don't have a hypotenuse, and this is our adjacent. Okay, so we're going to use tangent here. So the tan of 47 is equal to the opposite over the adjacent, which is 8.5. Drop one underneath and cross multiply. So X is equal to 8.5 times the tan of 47. And so what we get for our height is X equals, let's just put this in the calculator. It's a straightforward calculation. We get 9.11513. Remember, put as many decimal places as you can. You don't want to get any rounding errors. Now we want to find our three volumes, right? Now that we got the height of our cone, we can find our three volumes. So we got the volume of the hemisphere, which is 4/3 pi r to the third, right? That's the hemisphere. Let's put some labels here. We got our cylinder, which is volume equals pi r squared times height. And then we have our cone, once again, is volume equals 1/3 pi r squared times height. Let's plug in our numbers. So for our first one, we get volume is equal to 4/3 pi, and our radius is 8.5 to the third power. Remember, we're going to divide that by 2. What we get here is, let's see, we get 1286.22039. All right, so that's our first volume of the hemisphere. Then if we do the cylinder, what we know is this. We have pi. The radius is once again 8.5. We're going to multiply that by the height, which was 25. All right, you can look on the other paper if you need to take a look at that. Oh, we forgot the radius is squared. If we put this into the calculator, we get the volume is 5674.50173. All right, remember, I'm not rounding anything. These are all the numbers from the calculator. And for the cone, we're going to do the volume is, all right, let's move this down here, 1/3 times pi times the radius, which is 8.5, that's squared, times our height, which is, oh man, I'm running out of room, 9.11. Put all of that number in there, okay? And what you should get is the volume is equal to 689.65125. So here we have our three volumes that make up the whole water tower. 1, 2, and 3. What you do is you put these in the calculator, you're going to add them all together, and you get your total volume is equal to 7650.37337. And this says rounded to the nearest cubic foot, so that means no decimal places. So our final answer should be the volume is equal to 7650 cubic feet. All right, so that is our total volume. All right, no rounding errors, everything done perfectly. All right, now the next part of this is an interesting question. The water tower is constructed to hold a maximum of 400,000 pounds of water. If water weighs 62.4 pounds per cubic foot, can the water tower be filled to 85% of its volume and not exceed the weight limit? Justify your answer. So this is how we're going to do it. We're going to first find the weight of this water tower if it was filled totally with water. So remember, weight is the density times the volume. All right, so what we're going to do is find out the density, which is given to us as 62.4, and our volume is given to us as, well, we figured that out, 7650. So you get the total weight if this thing is filled totally with water as 477,360 pounds. So that's the total weight if it's full 100%. Well, we need 85% of this, so what we're going to do is take this number and we're going to take this and multiply it by 0.85 because this tells us if it's only filled to 85%. So the weight of that would be, well, 85% of 477,360 would be 405,756 pounds. And that would be the weight at 85%. All right, so this is 85% of the weight. All right, now the question is, can the water tower be filled to 85% of the volume and not exceed the weight limit? Well, it says the weight limit is 400,000. Obviously, this is more than 400,000, so the answer would be no, it would exceed the weight limit. That's bad. It's going to break your water tower. And that is it. All right. But remember, weight is just density times volume, and we got 85% of that. It's more than the total maximum capacity. All right. Final question. In the coordinate plane, the vertices of RST are 6, -1, S is 1, -4, and T is -5, 6. Prove that RST is a right triangle. Well, we know that this is from level 8. This is coordinate geometry or applications of. All right, I'm abbreviating a lot here. And if you really want to look at how to prove a right triangle, just go to lesson 8.2. That's actually called proving right triangles. And you might remember, to prove something's a right triangle, what you're going to do is actually find the slope of all three sides. So this triangle has, the three sides of it are, if you were to look at it, it's RS, ST, and RT. All right? And we need the slopes of all three sides here. All right, and you know what? Let's just do it the easy way. We're going to count it. So let's go to the graph on the next page. They gave us a nice little graph here. Let's just graph our points. So R we know is at 6, -1. So this is our R. We know S is at 4. 1, -4. So this is our S. And T is at 5, 6. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. This is our T. All right. Now to prove that this is a right triangle, we need to find the slopes of all our sides. All right. So let's find TS first. So we'll find this first slope in proving it. So to find the slope, we'll just count it down, right? So we count left to right, so it's down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 down, and then 1, 2, 3, 4, 5, 6. 6 over. So the slope of TS is negative 10 because it went down over 6, which reduces to negative 5/3. All right. Now we'll find our next slope of SR. The slope here is we go left to right, so we're going to go 1, 2, 3, 4, 5, and up 3. So 5 and 3. So RS, we'll put that down now, is positive 3, because it's up 3 over 5. Now you could keep finding your slopes, but if you look here, these two are perpendicular. So we've already proven that this is a right triangle. So in conclusion, we know that triangle RST is a right triangle because TS is perpendicular to RS. Right? That proves that this is a right triangle because if two sides are perpendicular, it must give you a 90-degree angle. So step 1 of this has been proven to be true. Proven to be a right triangle. Now let's go to the second part of this question. Second part of this question says this. State the coordinate of P such that quadrilateral RSTP is a rectangle. So we're trying to make a rectangle out of these 3 points. And what we're going to do is this. We're actually just going to use the property that opposite sides are parallel. So if to get from S to R, I go to the right 5 and up 3, it's going to be the same thing to get to T to my next point. So watch, this is all you got to do. You got to count 5 over, 1, 2, 3, 4, 5, and then up 3. And you see what I've done there? I've actually just created a parallel line to SR. So if you go like this, well, look at that. It looks just like a rectangle. You just had to count the same amount. So this point P, is at, well, let's write that in. That point is 0, 9. And then finally, it asks us to prove it is a rectangle. And there's 2 steps to doing this, to proving this guy's a rectangle. First, step 1 is to prove it's a parallelogram. So we want to show opposite sides are parallel. So here we go. We want to show that TP and SR are parallel. So we're going to find these 2 slopes. Right? Those are opposite sides. And then we're going to show that TS and PR are parallel. So we're going to find those slopes. So we've already found the slope of SR. That is up 3 over 5. So we know the slope is 3 over 5. We also found the slope of TS, and that was negative 5 over 3. So we just got to fill in our other 2 slopes, TP and PR. So TP is, well, we actually already found that slope. It's over 5, right? We have done this in up 3. So it's exactly the same slope. This is 3 over 5 as well. So that means we have 2 parallel lines. We have parallel lines here. And then P to R, well, we can count that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 10, and 6. We went down, so that's negative 10 over 6, which reduces to negative 5 over 3. Look at that, these are parallel. So step 1, we state that RSTP is a parallelogram because opposite sides are parallel. Now we got to prove it's a rectangle. That's step 2. All right, and the way we're going to do that is we're going to show that the diagonals are congruent. To show the diagonals are congruent, we have to use the distance formula. So we're going to find the lengths of TR, which is one of the diagonals, and we're going to find the length of PS. Now I'd like you to try this on your own and see what you get for those 2 lengths. And what you should get if this is done correctly, and I'm telling you, don't just wait, use the distance formula and see if you can actually find those 2 lengths. And if you do it correctly, what you should get is TR is the square root of 170 and PS is the square root of 170. And because your 2 diagonals are congruent, we know it's a rectangle. So now we can prove that RSTP is a rectangle because diagonals are congruent. The end. All right, that's it for this, Regents. Go kiss your mama and tell her, I studied hard. I studied so hard. I'm so proud of myself.